Hello, welcome to 8.5 Circles. Okay, so I don't know if you remember, but we had talked a little bit about the more sides a regular polygon has, the closer its shape approaches the circumscribed circle. Easy for me to say. The idea is what we used when we talked about circumference. So the more sides a polygon has, the closer you would get on that perimeter, the closer you would get to the circumference of its circumscribed circle. So if we have a triangle and we find the area of the triangle, we have a lot of space between the triangle's edges and the circle that includes its vertices. So this isn't the best example, but let's add some sides. Hopefully you can tell that you have even less square units between the square and the circumscribed circle. So here's an 8-sided figure. I'm getting pretty close. 12-sided figure, the lines are almost too thick to tell that there's space between the edges of the dodecagon and the circumference of the circumscribed circle. So the shape just becomes closer and closer to being a circle the more edges that you add to the polygon. Okay, here's a 20-sided figure. You can it's almost hard to tell there's edges on this particular polygon. Okay, so if you remember, we talked about a regular polygon is the area equals half AP, where A is the apothem and P is the perimeter. So we are actually going to do some deriving of the area of a circle. I'm pretty sure you already know this formula, so we're going to basically prove it. So if I replace the A, apothem, with an R radius, because as we get closer and closer to a circle, that apothem gets closer and closer to the size of the radius. If you go back and look at the last slide we did, okay, you'll see that that radius and the apothem are nearly the same. And then we know that the circumference is the same as perimeter, so I replace the P with a C. And then for circumference, I put in the formula for circumference, which is 2 pi r. So now let's go ahead and simplify this. 1/2 times 2 is just 1, and r times r is r squared, right? And that leaves me with pi r squared, because I don't have to write 1 pi r squared, right? Anything times 1 is itself, so it just is extra. So there is your formula for area of a circle. And that is exactly what our theorem says today. Now, there aren't any examples that I'm going to work with you, and there's none in the book, because I think you know how to find the area of a circle. I'm pretty sure you've done it 100 times before this class. So what I want you to do for your whisk summary, I want you to use the area addition postulate on this one problem to where you're going to have a semicircle. Now remember, a semicircle is exactly half a circle, okay? So that information will help you with the practice problem, and then the rest are areas of rectangles. So let's go ahead and look at it. I want you to find the area of this figure. Okay, so you have all the information that you need, so ponder it, and I will see you in class.